Hello everyone, welcome to my channel Chaya Kumar Sajidar. In this video, I'm going to discuss how compilation works whenever you build a program, any C or C++ file, how compiler compiles in each stages. So those stages will be breakdown in this video, and this is a short and crisp video. So let's get started. Okay, so this particular video is going to be part of my embedded system playlist. So I would encourage you to watch all of these three videos to maintain the continuity of my playlist so that you guys are in sync. And I have provided, you can click the link above. And of course, you can also check the link for the description box regarding the embedded systems playlist. Now let's get back to the video and discuss about the compilation steps. So there are several stages in the compilation. The first stage is called the processor. Second stage is compiling. Third stage is assembler. And the fourth stage is linking. Now let's get deeper into each compilation step. So talking about the pre-processing. So in your C or C++, you have hash include, hash define, or pound define, whatever you guys call, and conditional compilation, like if and def, do this, else, do this, and if. So these three things is called conditional compiling. So all of these are actually resolved. For example, when I say resolved, so for say, let's say like when you do hash define some max val equal to 10. So and wherever you use this max val macro in your C or C++ code, that max val will be actually replaced by 10. So when during the first stage of the pre-processing, your input would be .c or .cpp file, and the output will be .i file. So it will resolve all these things and give it in a .i file. So this is about the pre-processing stage. So after pre-processing stage, let's continue with the compiling stage. So in the compiling stage, previously we got .i file, right? So that will be converted into .assembly or .s file. So compiling. So what it does is, suppose if you are actually compiling for the ARM32 instruction, so the assembly code for the ARM32 instruction will be generated. Similarly, for ARM64, as ARM64 assembly code will be generated, and x86, which is Intel processor. So assembly code for the Intel processor will be generated. And before even generating the assembly code, it does syntax checking. So you guys will actually often see the syntax error, different kind of syntax errors, right? All of these things will be done first, and then generation of assembly code happens second. So this is all about the compiling stage. Now let's move on to the assembler stage. So what is this about assembler stage? Again, assembler stage take the assembly input and then it will convert into .o file. .o as in object, .object file. Some people call it as a relocatable object file as well. So what is so special about this relocatable? I'll be explaining in a while. So assembler will convert dot s, that is assembly file, to .o file. Moreover, this .o file contains opcodes. So what is this opcodes? So opcodes are generally the machine level instructions only the processor can understand. For example, you have move instruction, the assembly move instruction, str instruction, the store instruction, load instruction. Like that, there are multiple instructions, right? Each of those instruction will be having its own opcode. So that the processor can understand those opcode. So it just comes in different values, integer values translated into binary codes. So machine generally understand the binary codes, right? So that is what the opcode is. So this is about the object files, assembler stage. Now let's continue with the linking stage. So the linking stage takes the relocatable object file and then convert into .elf file. So what does this .elf mean? Elf as an executable linker format. So why am I actually talking about relocatable often? So because relocatable will just contain the machine instructions, right? All the opcodes, but they don't know where to execute. So those opcode needs to be relocated in the proper addresses. How do we actually relocate? So for that we have something called as linker script. So the job of the linker script is it actually provides the starting address of the RAM and the starting address of the stack and the starting address of the heap. So linker script will actually provide all of this. And in my upcoming videos, I'll be actually showing you guys how to write the linker script. So I would like you guys to keep following my embedded system playlist. I'll be doing a lot of exciting things. So the linker script will provide all the information to the .o file. So based on that information as in addresses information, those mnemonics will be assigned, relocated to different address. So that's the reason I'm actually stressing the terminology called relocatable object file. So it means the mnemonics can be relocatable with the help of linker script. Once all these things are resolved, the output will be L file. So this is what gets executed in the hardware, on the hardware basically. So that's what ELF as in executable linker format. So yeah, this is all about compilation step, guys. So to continue further, I want you to guys download the compiler. So in the Google, actually search GCC for ARM and click on the first link and download based on the host machine that is you are running. In my case, I'm actually running on the Windows machine. I will download this. If you are running on Linux or Mac, whatever, there's a download respective compiler. So I would encourage you guys to download the compiler. So once you download and done with the installation, go to the program file, and here you should be seeing the GNU ARM embedded tool chains and ARM and EABI bin, and these are the compilers application that you see. GCC, ARM and EABI GCC is for compiling the C code. And G++ is for compiling the C++ code, and .as is compiling the assembly code, and .ld. This is what the linker application is. So the linker application needs the linker script. So whatever the one that I discussed in the linker script, the .ld will actually take care of linking and producing the final .elf output. And in addition to this, I would like to talk about something called as AR. What is this AR all about? AR stand for archiver. Like even for the archiver, you can actually provide a relocatable object file, and archiver will actually convert into library, static library. And this static library does not contain any address information. You don't field any linker scripts for this. You just provide the library. And in most of my application, I won't be doing this. I won't be using about archive. I won't be using archiver. I just wanted to give an extra information. Take it like as an extra information. And there are certain scenarios where during the linking stage, along with the linker script, you also provide .a file, that is static libraries. So .a as in static libraries. Static libraries, you provide the static libraries as well for the linker script. And moreover, this is optional and this is mandatory. Providing the linker script is mandatory. This is optional. And I won't be covering the providing the optional static libraries in my video series because it doesn't serve anything. Anyway, I want you to guys download this and be ready with the compiler by the next video. And to ensure that you're able to compile successfully, make sure you run this command and you see this output. So in case if you don't see this, you might be missing, you might have to add the path for the bin in the environmental variables. and then open a new command terminal and try running this. So with this video, you will be done with the compiler setup in your host machine. And stay tuned for my upcoming videos. I'll be doing more exciting stuff like writing the drivers for the STM microcontroller, and I'll be showing you what kind of STM microcontroller that I'm using. And STM microcontroller is based on the ARM processor. The ARM processor that is used by the STM microcontroller is based on 32-bit. That's the reason you downloaded the ARM None EABI. So ARM None EABI is a 32-bit compiler again. For 64-bit, it will be called as Arch64, but you don't have to worry more about it. Let's keep it aside for now. Stay tuned for my upcoming videos and be ready with your compiler and make sure that is you're able to see this. And yeah, stay tuned, guys. And I'll be doing a lot of exciting stuff. Like I said, happy learning. Keep watching Chai Commerce Entertainment, especially embedded system videos, if you're keen to learn about embedded systems. Thank you.